Welcome to section 2.7. This section is entitled Logical Arguments. There's a lot of things that this section could have done. It could have had us verify arguments, and in some ways we are, but what it chose to do, and our book chose to do, was illustrate three types of arguments. And so the first one is called the law of detachment. And the law of detachment talks about if you have a premise, if you know that P implies Q, and you also know that P has been met, then the conclusion, and I'll put a line here, the conclusion would be Q. So again, I'll use an example that I've used in past videos. If you pay me $100, then you'll get an A in the class. And you know that the person paid me $100, then the conclusion is that they'll get an A in the class. That's the logical thing to happen. If you run out of gas, then your car will not run. You ran out of gas, therefore your car does not run. They use a symbol. I just use the word therefore. If you're reading the book, therefore has a symbol. Therefore symbol is three dots that kind of form a triangle. So when you look through the book, they will have, for the conclusion, since it is a conclusionary piece, not a premise, they'll have a therefore Q. Okay, that's the law of detachment. And what the homework does is has us practice with that. I want to get out all three laws, right? And that's all they do is have us identify which law we're talking about, and when we, or what's the logical conclusion that we could make. So you have the law of detachment. The next one is, in the way that they present it, the law of denying the consequent. So let me write that out. The law of denying the consequent. Now I'll talk about this one a little differently than the first one, but I could have talked about the first one that way. There's two premises. So premises are things that you know are true. If these two things are true, then the other thing happens. So the first premise is that P implies Q. The second premise is that Q didn't happen. So if the promise is true that if you pay me $100, you'll get an A in class, and you see that somebody didn't get an A in the class, then the conclusion would be very natural. Oh, well then they must not have paid you the money. That first thing must not have happened. So, again, talking about it, if the first premise, P implies Q, is true, and you realize that the consequent didn't happen, then the initial statement, which they call the hypothesis in our book, didn't happen. Hey, if it's true that if you pay me $100, you'll get an A in the class, and it's also true that you didn't get an A in the class, then you must not have paid me $100. Okay, that's the law of denying the consequent. And then there is, I think they just call it the chain rule. And they call it the chain rule for conditional arguments. They feel like these three rules happen all the time, so they just want us to practice with those. So the first premise is very similar, that P implies Q. The second premise that we assume is true is that Q implies R. And so the logical conclusion would be, therefore, well, if P goes to Q and Q goes to R, then P will go to R, right? That kind of makes sense in that whole process. Then P will go to R. In the book, they establish truth tables to show that these do present valid arguments, but then in the homework, they never ask us about doing the truth tables. They just are concerned with us knowing these arguments. So I'm going to come in here and I'm going to separate these, not with a line because they have other lines involved. I'm going to separate them with a highlight, right in between here. So those are the three things that we're going to be working on and working with as we go through the homework. So as we go into the homework, and you're basically doing the whole section, it says for the following exercises, analyze the argument and identify the form of the argument and determine whether we're denying the consequence, the chain rule, or if we're using the law of detachment, which one's being used. So I'm going to try something really quick. I think I have this open. If I don't, I will quickly go there. Yeah, it's not to the right section, but I can get there. So let's go look at some 2-7 problems together, rather than me type them out or try to copy and paste them, or worse yet, write them down. Let's take a look, right? They're presenting all those rules, and here's the 2-7 exercise set. So if we look at number 2, they just want to know, am I looking at the law of the consequent? Am I looking at the law of detachment, the law of denying the consequent, or the chain rule? And so if we look at number 2, it could actually be none of these. So let's look at number 2. In the animated movie Toy Story, if Paul Newman turned down the role of voicing Woody, then Tom Hanks was chosen for the role. Tom Hanks was chosen as the voice of Woody. Therefore, Paul Newman turned down the role voicing Woody's Toy Story. Voicing Woody in Toy Story. So, what do we have? We have Paul Newman turning down the role, going to Tom Hanks being chosen for the role. Tom Hanks was chosen for the role. So, it looks like what we have, I don't know if I can write on this. Doesn't look like I can. So, if we look at number 2, I'll go to a pen here. If we look at number 2, we have Paul Newman turning down the role, going to Tom Hanks getting the role. We know that Tom Hanks got the role, therefore P must have happened. Okay. So if Paul Newman turns down the role, then Tom Hanks gets it. Tom Hanks got the role, therefore P. Well, does that match any of ours? And let's make sure. As I look at the second one, Tom Hanks was chosen as the voice of Woody. Okay, that's just Q straight out. This is none of them. This is none of those because it doesn't match the first one, and it doesn't match the second one. It doesn't match the first one because it's not Paul Newman being talked about, and so it's not P again. And it doesn't match the second one because it's not saying that Paul Newman or that Woody did not get the role, right? So this is none of those arguments. So that's good that they would have put that in there. Let's go look at what's next. If we look at something like number 6, if all people are created equal, then all people are the same with respect to the law. If all people are the same with respect to the law, then justice is blind. Therefore, if all people are created equal, then justice is blind. Well, those are two separate implication statements, two separate conditional statements, and they are joined in the middle. So all people created equal is headed to respecting the law. Respecting the law is going to justice is blind. So yeah, so number 6, we would simply say, so in number 6, if I were to diagram it out, we have P going to Q, and then we have Q going to R, and then they do produce the bookends. So this is the chain rule. I think you can just write chain rule. I don't think you have to write the whole chain rule for conditional arguments. So the answer for the first one, for number 2 that we looked at, is none of them. 6 is an example of the chain rule. And that's what's happening as you're working from 1 to 8. So as we look at the next block of problems from 9 to 14, it says, for the following exercises, each pair of statements represents the premise in a logic argument. Based on these premises, apply the law of detachment to determine and write a valid conclusion. So the only one we're focused on is this very first one, the law of detachment. So that law of detachment says if P is going to Q is true and P happens, then Q is going to happen. Okay, so let's go look at this. So if we look at 10, negation of P goes to Q and the negation of P. So number 10, if I write out what they have there, number 10 said, and let me look at that again, the negation of P goes to Q. Negation of P goes to Q. And we have the negation of P, which is the first thing. Therefore, we have Q going on. Now notice that this is the same thing. I think they're looking to trap us with the negation. But what the law of detachment says, it says if you have one thing going to another and the first thing happens. So I have the first thing going to the second thing and the first thing happens, therefore the second thing happens. And so it's just writing out Q, I guess, and write a valid conclusion. The valid conclusion would be Q. So if we look at 14, if Peter Rabbit lost his coat, then all rabbits must avoid Mr. McGregor's garden. Peter Rabbit lost his coat. The conclusion is all rabbits must avoid Mr. McGregor's garden. And what's going to happen in the next block is you're going to do the same thing, but with the law of denying the consequent. And in the last block, you're going to do the same thing with the exception of using the chain rule. So let's go look at that chain rule. Let's look at something like number 24. Now, number 24 says the negation of R goes to P. Let's see if I can copy it. I don't think it likes these symbols, but we'll see what happens. Nah, it's not letting me copy. But the negation of R goes to P, Q goes to the negation of R. The negation of P goes to, am I remembering that right? Oh, the negation of R goes to P. So, and that was number 24. The negation of R goes to P, and Q goes to the negation of R. They'd like us to use the chain rule. So remember, in the chain rule, you need a common middle. The common middle is definitely the negation of R. And we have to respect the order of the arrows. And so if we respect the order of the arrows, we need Q to be first because it's going to the negation of R. The negation of R is going to P. Therefore, Q can go directly to P. This is our conclusion. Q goes directly to P using the chain rule. Okay, and they give it in words here. And then we have these last groups of problems as well. So you get an opportunity to see the rules in play, to apply the law of detachment, followed by the law of denying the consequence, followed by the chain rule, which we looked at. And then we have state a valid conclusion. So what's going to happen in these guys is that they are going to be any of them. So let's look at 30. If all fleas bite and our dog has fleas, then our dog will scratch a lot. Our dog will not scratch a lot. So what's this one? This is the law of denying the consequent because you have the second thing not happening. So if I look at the law of denying the consequent, because that second thing didn't happen, then the first thing didn't happen. And so if all fleas bite and our dog has fleas, then our dog will scratch a lot. Our dog didn't scratch a lot. So we would have to say something like, it is not the case that all fleas bite and our dog has fleas. Or we could use De Morgan's laws to say some fleas don't bite and our dog does, or our dog does not have fleas. So they can get into some semantics there. So 30 and 30, well, 30 in particular, but you'll do the same thing in 31, is nice because you can use De Morgan's laws. Let's look at 32. If you do not like to dance, then you will not go to the club. You went to the club. So this is also a denying the consequent because that second thing didn't happen. Sorry, I shouldn't have double tapped there. That second thing didn't happen. So what do we have? We have the first thing not happening. That means we do like to dance. And so they don't get harder and harder as we go forward. And so that's what's happening as you do the homework. I think your homework stops in 31, but let me just double check that. Does your homework stop at 30? It does. It stops right there at 31. So you're going to just be getting really familiar with 3 concepts, right? Again, you can write them down and use them as you go through the homework. The law of detachment, the law of denying the consequence, the chain rule for conditional arguments. You're going to get really good at identifying those and using those to your advantage. So I hope it goes well.